Okay, we're recording now, and Mod 7 would like to say,
Hi. Hey, Mod 6.
now we're going to forget that you're there. Okay? All right. So if you want to refer to the textbook, this goes along with material in chapter 10.3, where they give you about 3 examples, and then I'm going to give you about 600. Okay? Okay? Properties of logs. Math people love the short things. While I love the word logarithm, most of us don't actually say the word logarithm very often. We just say log because it's short. It's what we like. Okay? I need you to remember that the log of a number, and I say, what's the log base 3 of 7? What's the log base 10 of 12? What's the log base 2 of 8? When I ask you any of those questions, that answer represents an exponent. So that when you are working with logs, you are working with exponents. And so there's going to be a connection in how you work with logs and how you work with exponents. They're going to be connected, and that's what we're going to look at today. Now, we're going to do a little mini proof. You do not have to reproduce this proof, but I would like you to follow it and understand it. Okay, when you're in geometry, you have to produce your own proof, but not in here. Okay, I'm going to write something down. 2 things. And I'm going to tell you that we're going to start off with the assumption that these 2 statements are true statements. That if for some base b raised to some power of x, the answer is m. Okay? And for that same base b raised to some different power y, the answer is n. So just assuming that this statement is true, then I want to make sure you follow everything that I do after this. Okay? So you're going to stop me if you have a problem. If that first statement is true, do you see that the second statement is also true based on our new notation? Yes? Okay? And that one is also true. This is just transforming from exponential form into log form. Yes? So if I said, what does x equal? You would say log base b of m. If I said, what does n equal? You would say b to the y. Do I see? Okay, so those are our starting points, and we're going to use them as we go through this problem. Consider b to the x times b to the y. Now, I'm pretty much not going to use anything but rules of exponents that you already know, and this starting point up on the board. Okay, so look up here. What does e to the x also equal? No, m, right there. See it? Okay, so I'm going to put m here. And what does b to the y also equal? Yeah. Everybody good? So again, assuming the stuff at the top is true, this is also true. Yeah? Okay, now, what the rules of exponents tell us that if we have like bases right here, what can we do to those 2 exponents? Add them. So I can rewrite this as b dx plus y. Look at that. Now I'm going to rewrite as a log. I'm going to go from an exponential statement to a log statement. Okay, I made that one little change, and I'm going to go to a log statement. So it's going to be log base what? B of what? M times n. Sometimes we'll put those in parentheses. We'll put those in parentheses just for clarity. They don't always have to be there. And what is it going to equal? X plus y. Is everybody following? Again, you don't have to reproduce this, but I do want you to follow where it came from. Okay, finally. Go back up to the top of this problem. What did we say that almost at the very beginning? What does x equal? Back at the very top of the problem. Log what? What do we say? We don't just say log b, we say log base b of m. And what does y equal? Look at the top of your front page. Log base b. And consider this statement. This is a property of all logarithms, no matter what the base. Okay? And that is that if you have the log of a product, then if you want to, you can break it up into two separate logs with an addition of the log. Okay, and this is because logarithms are essentially exponents. And you know the rule about exponents, right? When you multiply, when you have these two exponents and you're multiplying like bases, what do you do to the exponents? Add them. And that's where we get from this part of the log in the multiplication problem, we can break it up into addition. So I'm going to give you a numerical example, well, part numerical example. Okay. We want to use this property of a log to write this as an addition problem. Okay? So the first one would be log base 3 of 2. And we're going to break this up into its two pieces right here. Log base 3 of 2 plus log base 3 of x. You can do this when you're working with variables. You can also do this when you're working with numbers. In fact, before the day of the calculator, we had to do this a lot in order to figure out what things were equal to in a way that we could understand them when we didn't have calculators to push. We still use it mostly for variables. Okay, so I can use this property to break this up. Log base 5 of what? 4, the first one. Plus log base 5 of, okay? Now, understand, I'm not saying you have to do this always and forever. I'm saying that it's useful, and that you can do it when it is useful to you for some reason. Does that make sense to everybody? Okay, now I have another a nice little tidbit I want to point out that's been pointed out before. Do you see how this base is a 5 and how this is a 5 right there? I want y'all to think about this creature for just a minute. If I had put that on your homework last night and said evaluate, think, don't say the answer out loud, or write down a little bit of work. What could you replace that with? So our little think step is 5 to the what is equal to 5 to the 1. So what does all of this green stuff equal? This equals 1. So this is going to be a piece that pops up every now and again when you're working with logs, and you want to kind of recognize it. Log base 5 of 5 is 1. Log base 6 of 6 is 1. Log base 7 of 7 is 1. Another little comment, when you learn something new, there's a lot of notation to learn, a lot of getting used to how to write things. This is considered confusing because someone might not understand, is it this log of 4 or is it the log of 4 plus 1? Can you see how somebody might not know the difference? Okay, so you need to do one of two things. You either need to put parentheses around that whole log, or you need to move the 1 out into the front. That's the choice I would do then. And this is similar to when we were doing like the square root of 2x plus 3. We had to make it clear whether that 3 was in the radical or out of the radical, and so we usually turned it around and put it this way. Yes? I'm supposed to do 2. I have to do it. Okay, so same idea, just making sure it's clear. All right? Everybody follow? Okay. Let's do another one. Forgiven. Actually, the same given. We're going to do something else first. Same given that was at the top of the other column. time I'm going to consider the division question. B to the x divided by b to the y. Okay. So again, look up here, right up here, and tell me what can I replace b to the x with? Be careful, be careful. I'm going to do this again. I'm going to reach up here and I'm going to point to something. If I say, what does n equal? Everybody look, what does n equal? Find one of these things up here that says n equals. Where is it? Here. So what does n equal? B to the y. If I say, what does x equal? X equals log base b to the m. Do y'all see? If I say, what does m equal? M equals b to the x. If I say, what does b to the x equal? It equals m. Do y'all see? You gotta make sure you grab the right thing. So b to the x equals m. What does b to the y equal? Again, so here's our starting point. Given that those first four statements are true, then this statement is also true. Okay? And using the properties of exponents, when we have like bases that are being divided, b to the x divided by b to the y, what can I do to the exponents? Subtract them. Good question, Maggie? Okay. So I'm going to write that just a little bit simpler. And now I'm going to write in log form and see what happens when I transform from exponential form into log form. Log base b of m over n is equal to x minus y. Okay. Now I'm about to ask you a question, and it's run off my screen, so you can't see it. You're going to have to look at the top of the problem for your own on your own paper. What does x equal? Log base b of m. Everybody see that? And what does y equal? Log base b of m. This is our second property of logs. Again, connected to the fact that logarithms are exponents, and when you have a bases, like bases, with exponents, and it's divided, like right here, you can subtract the exponents. So when we are looking at logs, and we have the log right here of a division, we can convert it into two separate logs with subtraction, and it will say the same thing, just written in a different order. Okay? Let's practice one. Try to read my own handwriting. So log base 2 of x divided by 5. Y'all see how this steps the format? It is the log of a quotient. So I'm going to be able to write that as two separate logs. Log base 2 of x with a minus log base 2 of 5. I didn't say you always have to do it. I said you can do it. It's one of the things that you are allowed to do. Log base 3 of 3/5. Log base 3 of 3 minus log base 3 of 5. Back in old days, pre-calculators, the back of our textbook had 15 or 20 pages called log tables. Log tables gave us logs of certain values, and so if you were asked to find a log value that wasn't in the table, you had to do this and go look up these two values and subtract them to get the answer. That's the way we used to do it. Okay, and you should say right now, thank goodness we don't have to do that anymore. Okay, now one of the things I need you to start looking for, this wasn't on last night's homework, is you need to start looking for that creature right there. If it pops up, log base 3 of 3, log base 5 of 5, log base 10 of 10, what does that equal? 1. All right, so far so good? One more, that's it, just one more. only use one of them this time. I use both of them. So far, up until every time I've rewritten in log form, I put the log in the front, but you don't have to do that. Can y'all see that this time I just put the log in the back? Okay, it doesn't make any difference, whichever way floats your boat, okay? Consider. What if I take v to the y, and I raise it to some other power, and I'll just pick a letter, any letter, and I call it k, yes ma'am? Oh, that's right, this is the y now. Remember, I picked that, please just tell me the next, so it's the y. On my paper, it has an X. But let's just stick to one here. Okay? So, what can we do if we say v to the y equals p? Okay? What else can we write down that's also true? Well, what is another way of writing v to the y? What does v to the y equal? Now, so these two things are the same. And we're going to look at the property of exponents that says, what can I do when I have a base raised to 2 powers? What can I do to them? Multiply them. And so that'll be v to the yp, or y times p. Equals m to the p. And the next thing I'm going to do is write this thing in log form. Let's see if you can write this in log form. Log base of, what do we want to say, m to the p. Yeah, that's what I want to say, m to the p. Come on, kids, go ahead and say it, m to the p. Equals what? Y times p. Finally, log base of m to the p is equal to, go up there and look at the top of this problem, and what can we replace y with? Log base b of, yeah, and I just moved that p to the front instead of having it in the back. This is our third and for today final property of the logarithm. Things that we are allowed to do with logarithms. Just like when we learned with exponents, when you add them, when you subtract them, when you multiply them, there are similar properties to logarithms. Okay? Let's do a couple of quick examples. Straightforward one, and then we'll look at the more interesting ones. Log base 2 of x squared. Now, the first thing is to make sure that you see the structure. This is a base to a power. That's what it's looking at, base to a power. Does everybody see the structure? Okay. So what we can do is we can take this power here, pull it down, put it in, oh, only it's not p. What is it? Log base 2 of x. When you're in pre-cal and you're working with these, you're going to use this to make it so much easier to solve equations. It's not even funny. It makes things so much easier. Okay. Do you see that it fits the structure? The log of a base to a power. Okay? So what can we pull out from the front of this? 2 times log base 5 of 25. Now, that's using the property. That's the correct answer just for using the property. But I want you also to be looking for logs whose answer you know. You know how we're not 100% comfortable with all logs? Some of them are hard, but some of them are not hard. And this is where you just start getting comfortable with them. Log base 5 of 5. So look up and think. 5 to what power equals 25 squared. So that means that the log base 5 of 25 is 2. And that whole thing up there is just equal to the number 4, even though it has the logs in it. Okay? All right? 3 properties. Right? 3 properties over the course of how much paper? Page and a half, and maybe right. So right here, it's possible that you would be well served to all 2 of these properties in one place, right next to each other, so you don't have to keep going around the property. So that's what I'm going to do. You can write in here if you want to. We've got 3. The log base B. I use the same letters I use in class. Log base B of m times n is equal to the log base B of m plus the log base B of n. The log base B of m over n is equal to the log base B of m minus log base B of n. And finally, the log base B of m to the p, any letter you want, is equal to p times log base B of m. These are our 3 properties, and we're going to use these 3 properties to mess around with log statements, to see how we can change the way that they look and the different ways that they can be written. So good to go. One way to learn new properties is to write them over and over again. So as you're working through this and you do your homework, you might want to write these down at the top of each page, stop and write them over again, and then you'll start to internalize them. Okay? Because they're just the same kind of rules. Like, you know how you don't even really think about it now? If I say, what do you do here? You know the answer is multiply. But the first time you ever did it, you got mixed up about when to multiply and when to add. Okay? So this is the same thing that's going to happen with these problems. You have to keep looking at them until they become part of it. We're going to do 2 kinds of things. We're going to expand using, that's the letter A, using log property. We're going to expand. That's our first thing. I've got 6 of these I want to go through. Okay. Okay? And your job is to identify which of the properties you're supposed to do, and if you're supposed to do more than one of them, which order do you need to do them in. Okay? So this is a product, so we're going to use the first one up the top. So this is pretty easy. Log base 4 of 6 plus log base 4 of 8. Okay? Take a look if you get all numbers and ask yourself, is that one that I should be able to do in my head? 4 to what power gives me 6? Not one I should just be able to do in my head. Agreed? So we're just going to leave it like that. Okay? The second one. Log base 2 of 4 over x. Okay? So which property am I going to use? Where I switch it to addition or where I switch it to subtraction? Subtraction. So log base 2 of 4 minus log base 2 of x. If a piece of this has only numbers, you're going to ask yourself, is this a log that I ought to be able to write the answer down to? Okay, so this one right here says 2 to what power is 4? The answer is 2. So this log right here, this one, needs to be replaced by the number 2. The difference in that one and this one is that when I say 4 to what power is equal to 6, it's not a nice, easy, quick number to again. Yes? So when that's the case, you just leave it alone. Don't let it worry you too much. All right, next one. Log base 5 of x to the 3rd. Okay, everybody recognize that as the 3rd property. Yes, it's a log of a base to a power. So we pull that power out front 3 times. Log base 5 of x. thing that's going on here that was different. First of all, everybody see that it's a product. Yes? How many things can you multiply together? 3. 1/8, the x, and the y. So I need to break this up instead of into just two pieces. I'm going to break it up into 3. Log base 2 of an 8, plus the log base 2 of x, plus the log base 2 of y. Okay? Look at the numerical part. Look at the one that just has numbers and ask yourself, can I change this? That's what you actually see. That's just to keep y'all paying attention. Okay? Log base 2 of 1/8 and ask yourself, should I be able to change that into some other simpler answer? Yes, because 8 is a power of 2, yes? Okay, and some of y'all are faster at that than others, but you need to go over and ask yourself, how do I do this? Okay, and that 8 is 2 to the 3rd, so this is, whoops, let me change everything to x. 2 to the x equals 2 to the -3. This can go on in your head, or it can go on in a piece of paper. Like sometimes you have to go over to the side and do a little bit of long division or a little bit of multiplying. This is the same idea as that. Sometimes you have to write a little subtract. So what does this piece become? -3. And then we just have those two logs. Log base 3 of 9x over y. Does everybody see a product and a quotient? Yes? Okay, so we're going to break this up into, we're going to keep the top together and we're going to keep the bottom together. We're going to start by saying the log base 3 on the top minus the log base 3 on the bottom. Yes? Numerator, denominator. And then we're going to take this one and break it up into the addition problem. Log base 3 of 9 plus log base 3 of x, and that subtraction is still hanging on its wheel. All right? Look at the, really now we've ended, yes. Okay, when there's only one number or one thing right here, keep the log of what, when it's just one thing, you don't really have to put parentheses. If you're ever unsure, then you should put parentheses to clarify. If you were going to put parentheses around this, you put it around each of the logs. Like you can here, and here, and here. But as long as there's only one thing right there, one digit, one variable, it's really not necessary. Okay? Okay, now we got to look at that first piece again, the piece that's all numerical, and ask ourselves, can we replace that with a number? Yes. Yes. What's the log base 3 of 9? That's not always going to happen. I kind of made it happen in a lot of the examples just to get used to seeing it. But if it came out to be something weird, you don't have to change it. All right, now this next one is very similar to that one. But it's got a little thing that we have to pay attention to. Okay, so once again, we're going to break this up into the top minus the bottom. See? Okay, and then we have to break this up into addition. So agree? Okay, so log base 3 of x minus log base 3 of 9 plus log base 3 of, oops, did I change something? That's a y. Sorry, a y. Anybody have any comments? Yeah, something's not quite right. Okay, look up here. These are both on the bottom. Both of them. They're on the bottom. They both are being subtracted. Everything that follows this subtraction, all of this is being subtracted. So what do I need to put here to show that all of it is being subtracted? Yeah? That'd be a good thing to put in color, those of you have your nice white color pen that's on the table. Or, if you want to, you can skip straight over that step. And just go ahead and distribute that minus, and put a minus on the two things that are supposed to have a minus on them. That's perfectly okay. Do you see why they both have to have that minus on them? Yes? And then I'm going to change this thing to a 2. And I'm kind of tired of writing. Really bad for 1. Okay, I'm going to give you 1. I'll see if you can get this one all by yourself. Okay? Okay. Let's see if you can see how to break that one up all by yourself. Like a random squiggle. 4. All right, did you all get the correct first step? Yes? Okay, and then we're going to use that last property. We're going to pull that exponent down to the front. And I don't have any logs that are all numerical, so that's going to be the end. We're good? Okay. That's called expanding. Okay. Never do anything in here. Forward. If we don't turn around and do it backwards. Okay? In the other direction. Okay? So this time I'm going to get it to be spread out. This time I'm going to get it to be spread out. And you're going to try to put it together. Okay? Now, just a comment, you can only use these properties if every base that you're working with in the problem is the same base. That's all we're going to have this year. In pre-cal, you'll learn how to deal with it when there's different bases. Okay? But if this is a 3, this has to be a 3, or these properties don't work. Okay? All right, so I'm going to pull this together. 1 log, base 3, of what? 5 divided by 2. The first one divided by 7. Everybody see? Those basically 7s on my paper that turned into 5. We're going to pull this all together. Okay? In general, you start from the left and you go to the right. So we put these two together. Right here. Log, base 5 of what? Of what times 2? 3 times 2. And what's 3 times 2? 6. So I'm going to go ahead and put the 3 and the 2, multiply together, get 6. And I'm going to take that answer, put it together with the last piece, and that's going to give me log base 5 of 6. Okay, condensing. Okay, pulling it all together. Any questions? Yes.
Can you simplify, like, the log
Okay,
base 5?
there are a lot of things you could do. Does everybody see this thing right here? Log base 5 of 5, what does that equal? 1. But our goal in this particular exercise is to pull everything into one log, so we don't want to take that out of log form, because then we wouldn't be able to put it in there, okay? But you certainly are going to need to do that sometime. That was number 2, right? This one.
Are they supposed to have 2 different faces?
They are not supposed to have 2 different bases. Okay, that was a mistake. They're supposed to have the same base. It doesn't really matter which one. I think it's a piece of shit. I could take my glasses off, it never works that well. Well, that's not true. It works out when I go to the grocery store and I can't see things I told you. What about brain? I can't read my own handwriting? I can't read this test. If I can't read it, it says try. I thought my kids would do that too. Alright, so we're going to pull this thing from the front, right there, and it's going to become the exponent. Yes? We'll do the same thing in the second part. Log base 2y. Wait. And then I'm going to deal with the plus. Pull them together. An x cubed times a y squared. Okay? It is slightly more complex. Everybody got that one? Like 2 far up. Those parentheses require us to think a little bit about what applies to what.
7, 8.
It's a z. Okay? All right. Ready? So where do we start? Bring 6. Yes? Okay, you could distribute that 3 first, that would be correct also, but I'm going to start inside the bring 6. So 3 times log base 2 of x over y plus log base 2 of z. Okay? Then I'm going to deal with this 3. This 3 is going to become an exponent. And that exponent is going to be on what? The x and the y. Yes? So that 3 is going to go up on that xy on both of them. So that's going to be an x cubed over a y cubed. Y'all see?
Can you just do like a parentheses and...
Yes, but eventually you would need to put those 3 on both of them. Yes. Okay. And then I'm going to do that last one. Pull it all together and form a single log statement. Log base 2 of
X cubed
over y cubed times z. And you know, I can write it like that. But what would I really want to do with that? Where's that z going to go? In the numerator or the denominator? In the numerator, that's like z over 1. You do top times top and bottom times bottom. And so that z is going to be right there. I believe we'll practice the properties of exponents in the middle of logarithms. Yes? Okay, you know, I think I'll just stop right there. Okay. Seriously, be nice. There are some harder ones than this on your homework. Okay, there's a lot of nice simple ones, and there are a few harder ones. So work through the easy ones, easier ones. Make sure you're getting some comfortable with this new thing, and then just think out analytically, algebraically, and in order of operations when you get to the ones that are a little bit longer. Okay? All right, everybody say bye on 6.
Bye.
Good luck. All right.